So good morning, everyone. Lovely to be here. Lovely to see so many familiar faces. I've used this image in multiple slideshows since I took it in 2021. It's of the now defunct boat ramp at the Bullfrog Marina in Lake Powell. And not once when I showed it did I think I would use it to show how high Powell had been. When I took it, it was 3543. It's now 3523 and headed to minimum power pool, right? 3,500 by the end of this water year. And you're gonna see, I will caution you, some sort of depressing slides here, but I wanna start off saying I'm an optimist. We're actually gonna fix this problem. And I am fully confident that the people who are negotiating this are going to get this worked out. It will take time, though. So what's our outline? There's Eeyore, and I'm going to get to Eeyore in a second. So I'm going to review what happened this last winter. I'm going to talk about leaf area flows since 2000 and before, and the compact tripwire. I want to talk about Colorado River Basin temps and precipitation. Super El Nino, what it might mean. I want to talk about the PDO, the Pacific Decadal Oscillation, and future precipitation within the basin. Talk about global climate trends and end with some conclusions and thoughts. So why is Eeyore on the screen here? So for years, I've been called the skunk in the room, a moniker I wear proudly. Last year, however, I was called Eeyore at this conference, which is really a low blow, actually. Chuck Collin called me Eeyore. So, you'll notice that I welcomed you, right, with a good morning. Here's what Eeyore would say, if it is a good morning, which I doubt. Eeyore is just kind of a bummer to be around, right? I mean, he's just permanently depressed for no good reason. I'm depressed, but I actually have good reasons. I'm going to come back to Eeyore later. All right, so I'm sure everybody in the room is familiar with some version of this plot. The March 2026 snowmelt and our snow season. So the normal snow water equivalent plot here on the side, and the months of the year, October on the left going all the way out to July. Previous worst year is that purple reddish line, and there's 2006, right? The median is the green line there. So what are the lowlights? The lowest and earliest peak, earliest runoff by 4 weeks. So let's look at that a little bit differently here. So on this plot, I've got in red 2026, I've got 6 other crummy years, the crummiest years since 2000 on here. So 3 of those years had about 13 inches of snow water equivalent with 8.5 million acre feet of runoff. 3 of them had about 11 inches with 7.7 million. And this year, less than 9. Less than 9. And the only saving grace is this wetter, cooler period that showed up very late in April and into May. And without that, I wonder where we would be right now today. That is the saving grace of this year, if there is one to be found. So what about the April to July runoff forecast done by the NOAA National Weather Service, Colorado Basin River Forecast Center? 13% of average. Inflow forecast at 800,000 acre feet, 1/8. Normally it's about 6 million. It's below even 2002, which was the lowest year on record, just under about 1 million. And if you really want to get bummed out, look at that line at the very top of the plot. Max 1984, it says 15 million acre feet. We're 1/20th of that this year. So what about the temperatures in March? It's the warmest March nationally in 132 years. And you can see here on this image by NOAA, anything that's not in gray is a county that had a record high temperature in March. And the darker the county, the more the records that were set. And if you look at that, what jumps out at you? Colorado River Basin. 9 Fahrenheit above the 20th century. The first time we've had a month range to 9 Fahrenheit. Every CRB state had the warmest March on record and simultaneously really dry. So here you can see either much below average or driest ever. And interestingly or disturbingly, we now have areas in the West where the March record high temperatures exceed the April record high temperatures. And here's a version of that. So this is the day of the first 90-degree day in Fort Collins, 1895 to 2026, and every year gets one bar there. Days that repeat get multiple bars stacked on each other. The blue dotted line is the mean there from 1991 to 2020, and it's in June. Look at where 2026 sits out in March. It skipped a complete month. What about the flows at Lee Ferry? Here we have natural flows, 1906 through 2026. I estimated 2026 at about 6.5 million acre feet there. It's a little above 2002. Who knows if that's right, but it doesn't really change the numbers you're about to see. So 10.2 million acre feet the last 7 years. 20th century average at 15.2. The average now for the 21st century is 12 million. If you've been following this, that number's been like 12.5, 12.4, 12.3. It's now 12.0. 3.2 million acre feet per year. You add up the 27 years, that's 80 million acre feet of water we haven't seen in the last 27 years. What about the worst 27 years in the 20th century? 13.1 million acre feet. The difference there is about 30 million acre feet over the worst 27-year period. Lowest 7-year averages, you already know the 10.2 number, 11.9 in the 20th century versus this 10.2. These are all really big differences, right? Stuff we've never seen. So what about the Article D tripwire? That's the non-depletion obligation, and there's the language in the Colorado River Compact that says the upper basin will not cause the flows to fall below 75 million acre feet every 10 running years. So here's a plot that's Lee Ferry flow on the vertical axis. Each year from 1922 forward gets a bar for the Lee Ferry flow. You can see where Glen Canyon actually started storing water. The 2 lowest years, they were in the middle of the plot. You can see a red line, which is the 82.3 million acre foot flat tripwire, how we now interpret it, and the black line there is the running sum. If you look around in the 70s there, it dips down to 77 million acre feet. Kind of interesting historical note there. That's when they closed the gates those 2 low years I mentioned at Glen Canyon Dam, and it came back several years later in this low running mean, 77 million acre feet. I personally know about that because my uncle was Secretary of the Interior at the time and took a whole lot of heat from the lower basin for closing the gates at Glen Canyon. Look at the red arrow there over on the right side. End of this year, we're headed below 82.3. We will hit that tripwire. And importantly, and a little hard to see, and I don't have a pointer here, but there are a whole bunch of years there within the last 10 that were 9 million acre foot years. And those will drop off every year now, meaning we will continue to go below that 82.3 million per 10. What about temp and precipitation trends? So if you look since 1970, every month up significantly. We have an annual rate of about 3 Celsius per century. The global rate until recently is about 2 Celsius per century, and I'll talk a bit more about that towards the end here. And I'll note that the months June to December show more warming and more consistent warming, and it kind of makes sense. And at that time of year, it's really warm in the northern hemisphere, and it's hard to cool things off. What you see in the winter months is occasionally a cold winter month. What really concerns me is this table here, these 21st century precipitation declines. And I've got 3 periods. 2000 to 25, I don't include 26 because I don't have the data. I've got the period 2000 to 2019, and then the bottom is the last 6 years. And I break this into 3 periods, October to February, March to April, and May to September. So the first of these, for the entire period, that winter season down about 3%, nothing too bad. But then this quick transition into spring in March and April, and then in May and September, both significant declines in flows. If you go up to 2019, the winter period, October to February, shows very little decline in winter precipitation, yet very similar numbers for the rest of the year. But more recently, this last 6-year period shows significant declines in winter precipitation. And I would argue if these precipitation declines continue, and I'm not saying they will, but if they do continue and get worse, and you'll hear more about this on my slides on the PDO, the leaf area flow bottom is below any current projection. You may know that I've worked a lot on how temperature affect flows, and there's a good case to be made that as temperatures continue to increase, that temperature effect gets less and less. But precipitation works exactly the opposite way. If it goes down, the effect gets more and more. And so that's why these precipitation declines are clearly of concern. So what's El Nino? Let's talk about super El Nino. It's a pattern of sea surface temperatures in the Pacific. It influences via what they call teleconnections weather around the world, and you can see some of these impacts regarded to rainfall around the planet. It develops April through June, so right now. Maximum strength is October to February. It persists 9 to 12 months, but can last up to 2 years. It recurs every 2 to 7 years, and there's also La Nina and neutral. El Nino increases the odds of a wet U.S. Southwest. So right there where that circle is the wet Southwest, and a dry U.S. Northwest. So let's look at what's called an Enzo spaghetti prediction plot. And I need to explain 2 things before I show this plot. So one is I'm going to use something called the Nino 3.4 index, which is this place in the mid-Pacific there in that square box. And then Enzo, just so everybody knows, is the full name of this phenomenon, El Nino Southern Oscillation. So there's a spaghetti plot of Enzo predictions using both dynamical and statistical models. And if you have temperatures above 0.5 Celsius in that Nino 3.4 region, you get an El Nino. If greater than 2 Celsius, it's typically been called very strong El Nino. And the model average here for this year, which is that purple line there, is about 2.25 on the index. But you'll note some of those models go way high, way, way high, hence this idea of super El Nino. So what are these predictions, or what do they mean? And these are out of the NOAA's Climate Prediction Center. Basically, the 2 sentences here say it's likely to occur soon. And then the bottom sentence here is really important. Stronger El Nino events do not ensure strong impacts. They can only make certain impacts more likely. And in the image there over in October, November, December, and 2 other monthly periods, you see the predictions for what kind of El Nino we might have. And basically, it's equally split between these different kinds of El Ninos, including kind of fairly modest ones. So this plot I created, which is a scatter plot of leaf area flows versus that Nino 3.4 index. There are 120 dots on here, 1 dot per year from 1906 on when we have natural flows. And so La Nina's at the bottom, going to El Nino at the top, and low flows to high flows, left to right. Anybody see a pattern there? If you see one, you might want to see an eye doctor and maybe a psychiatrist. So there's no pattern. There's no relationship between Nino 3.4 and leaf area flows. But there are 3 dots at the top I'm going to talk about in a second. So if you take the top 12 in the Nino 3.4 index, there's no pattern there. See, they split either side of that line. And if you take the top 15 flows, a question nobody's really asking, but it's interesting anyway. What's curious about this is you actually almost see more high flows during La Nina than El Nino. But what about those 3 pesky dots on the top? So 2 of them have really big flows, 1983 at almost 24 million, 1998 at 17, but then you have 2016 there at kind of a modest 13.4. So you can always hope, right? And important to note that lower basin in California will in fact see higher precipitation. That's super clear about what we're about to encounter. So what about the PDO, the specific decadal oscillation? And I've got 2 pictures there on the top, the positive phase and the negative phase, and then also a version of the positive phase, which shows this classic horseshoe pattern. So what is this? So it's another sea surface temperature pattern discovered around 1996 amongst fishery biologists. Historically, unlike ENSO, on a 2 to 7 year pattern, it stays in one state for 20 plus years. And until recently, it was thought to not be a primary mode in the Pacific. It was influenced by ENSO and the Aleutian Low and this current off of Japan that's the equivalent in the Pacific of our Gulf Stream. It alters jet streams and storm tracks in the American West. The positive phase pushes storm tracks south, meaning a wetter US West. The negative phase pushes storm tracks north, meaning drier. And that leads me into 2 papers that came out last year. So this one's called Human Emissions Drive Recent Trends in North Pacific Climate Variations by a University of Colorado scientist amongst others. And this deals with this negative PDO trend and persistent western US drought. And the first sentence in this paper says, the Pacific decadal oscillation is not oscillating. It's been locked in this consistent downward trend for 3 decades. And they claim that this trend's largely driven by human emissions of aerosols, which originally were actually cooling the planet, and because we've now cleaned them up, they're helping warm, plus greenhouse gas emissions, which obviously cause the planet to warm. And until recently, the whole cause of this trend was undetected because models out there underestimate these impacts. And so on this plot here, you can see the models as they exist now, and that's a bell curve. You can see the model average down there showing a slight decline in western US precipitation. And then the observations are the circle there. They don't match, right? If you correct these models, which are the brown bell curve, they actually then reproducing far better what we have seen. And their takeaway is so long as greenhouse gas emission trends continue, PDO is going to remain negative, driving western US drought. A companion paper came out at the same time, Todd et al., called North Pacific Ocean Atmosphere Responses to Holocene and Future Warming Drive Southwest US Drought. And they looked at conditions 6,000 years ago. And you can see in this image kind of a warm Pacific and the brown, dry, arid western US. And basically it was warmer 6,000 years ago, and they said this warming in the northern hemisphere can produce widespread drought over the southwest US, and this warming causes this PDO-like pattern with significant 20% precipitation reductions. Future projections also show warming causes persistent negative PDO-like patterns. So they tie, again, into the models and what they're showing now. And they basically say the model deficits are underestimated. And the bottom line, persistent US drought is at much risk, higher risk in the US as it warms. And this line picked out the Colorado Basin. Such sustained drying and intense reductions in winter precipitation would have catastrophic impacts, particularly in the Colorado River Basin. And I'll note a 20% decline in precipitation is probably like a 50% decline in river flow. So, record ocean warming, let's talk about this. This is another paper that came out last year. It wasn't tied with those two, but boy, it dovetails in a really intriguing way by Kevin Trenberth, NCAR scientist, very well-known guy. So most of the extra energy the Earth is capturing is actually going into the ocean, right? We focus entirely almost on over land temperatures. You can see this extra energy, atmosphere 1%, land 6%, it's melting ice in the cryosphere 4%, and then bottom left, ocean 90% of this extra energy. And most of us, I mean, what's it mean to us? Why do we care that the ocean's actually gaining all this energy? Well, here's a look actually at that ocean gain. There's a time plot there on the left. Ocean heat content, OHC, 0 to 2,000 meters deep in the ocean. Zettajoule is the unit, which is like a bazillion BTUs. And then you can see a map of the world there. And what's intriguing about this, that's where it's warming. It's warming not at the tropics, but at 40 south and 40 north. 40 south and 40 north. So in the PDO region, we're seeing both higher sea surface temperatures and this deep warming. So here's in the Pacific, interesting plot through time, 2000 through 24 on the axis, and then latitudes on the horizon. And you can see as time goes on, that 40-degree north in the Pacific gets warmer in the deep ocean, and then you also see it at the sea surface temperatures as well. And this at least partially explains this stuck PDO phase. And one thing I'll note is if this ocean tries to get a little cooler, you then have all this heat underneath that can come back up, right? And warm up the sea surface temperatures. So why care? Well, this affects us. This affects the PDO. What goes on in the ocean doesn't stay there. So how about our scorecard dealing with climate? I maintain this is the only chart that matters. We don't control actually how where the temperature ends up. We control what we're emitting, the greenhouse gases. Here's a chart through time, 1850 through now. Anybody see any declines on that chart? If you do, there are recessions or global pandemics. Scientists since about 1980 have been saying maybe we shouldn't do this, and yet it continues to go up. It may, in fact, peak here at some point. You can kind of maybe think it's peaking there. The problem is the peak is like, I mean, that's not even beginning to solve the problem. That's just stopping from making it worse. So we're making the problem worse. And once this chart goes to 0, you'll have high temperatures for hundreds to thousands of years. And we're far from that net zero emissions policy we need. Same chart, same units on the side, and there's a net zero path. This is something out of the Rhodium group recently. They've done this for multiple years. Other groups have handicapped where we're headed. You see greenhouse gas emissions there not going down the way they should, staying flat through the 21st century with temperatures ending up somewhere between 2.8 and possibly more, and importantly, rising post-2100, right? Some of you may have heard that the IPCC just got rid of this scenario, RCP 8.5. Anybody hear about that? Well, the one that replaces it actually hits the same temperatures at 2150, 50 years later. This paper talks about how warming may in fact have sped up recently by two very well-known authors, and that period there circled from 2015 onward is what they focused on. They see a statistical increase in warming rate before 2015 at about 0.2 Celsius per decade or 2 Celsius per century, now at 3.5 Celsius per century, 75% increase in the rate. Causes maybe reductions in aerosols and changes in how the clouds are operating, which we don't completely understand. And we're going to breach the 1.5 target I mean, we already have effectively. All right, so let me end. And yeah, all kind of depressing, right? Eeyore kind of material. So in summary, no historical analogs for snowpack this year, annual and March temperatures, runoff last 7 years, runoff last 27 years. Climate future looks awful. Originally this read not promising, but Eeyore got a hold of it and changed it to looks awful. Much of the same and worse. And then here's my advice to water managers, where I'm gonna show, I hope, a little optimism. And I first want to call out this paper that Kevin Wheeler published back in 2022, What It Will Take to Stabilize the Colorado River. And he and his co-authors suggested that if you're going to stabilize the system using the flows up until 2022, so not what we've seen recently, these are flows like 12.5 million acre feet per year, it would take 3 million acre feet in lower basin cutbacks and an upper basin use limit of 4.5 to stabilize. And that's with, again, with flows better than we're seeing right now. So here's my advice. And let me just say, I have real faith and admiration and respect for those people negotiating this. They are at heart very good people in a very difficult situation. We have a very unique opportunity here to redo a system that's been in place for 100 years, and we can redo it for maybe the next 25 or 50 years. I have been trying to make the case that climate change has had really big impacts around the planet, but oftentimes these are one-offs. These are big floods, and they're big hurricanes, and people rebuild, maybe change building codes, and get on with their lives. This is a completely different situation, and I think it's unique around the planet in that we are going to get to redo, like it or not, 100 years of law and policy around how we manage a critical resource. And so we should not waste this opportunity. Give these negotiators the time and the space and the support to come up with a solution that'll get us through the next 25 to 50 years that look so problematic. And I'm going to suggest we need to buy out demand. I mean, we've got a much smaller glass right now. We've got too many straws in it, and we need to pull straws out of this glass. Getting through that hurdle will be hard. When you're on the other side of it, everybody will be so much happier. And then finally, here's my plea, and this is directed especially at the upper basin. We need everybody with a shoulder to this wheel. Yeah, upper basin, you didn't cause this. You can make that case. But yeah, you're part of the problem. And you know, if precipitation continues to decline, that 4.5 million acre feet of use you have, that actually may in fact be more than half the water we have. We understand the upper basin's different. We understand there are all kinds, they don't have reservoirs, and every year people suffer, but we need you to help. Please help us. So, I'm gonna end with Eeyore. Eeyore said, could be worse. Not sure how, but could be.
My God, that was depressing. Thanks, Brad. Let's see if I can do two things at once. Next up is Katrina Grant, who is with Reclamation and has been for about 20 years. Let me see if I can say this right. Your current title is the Upper Colorado's Deputy Regional Director, among other titles, I think. So she's the person to ask the question of how do we manage the infrastructure, specifically Glen Canyon Dam and some of the facilities upstream under extremely low reservoir conditions. And I don't know how candid she wants to be in answering that question, but she'll get her chance here. Before I bring her up, I just want to also say, welcome back to CU. She has her graduate degrees from CU, as do a lot of reclamation people. And I'm kind of hoping you don't remember you took a class that I co-taught, in 2003, my first teaching experience. I was horrible. That's why I'm hoping you don't remember. Carly Jurla was in that class as well. And I was horrible, but you and Carly both seemed to power through and survive the experience. So welcome back. I hope I didn't scar you at all. And let me see if I can figure out which one of these you sent most recently. I think that was the one. And, all right, all yours.
Thank you so much, Doug. Thanks for the introduction. Thanks for the warm welcome. It's truly a pleasure to be back in Boulder. In my research, in my graduate research here, I studied climate variability and how we can use that information to better manage water management in the Western United States. And I have the great privilege now to work for the Bureau of Reclamation. I love working for the Bureau of Reclamation. Let me just say that at the outset. After I joined Reclamation about 20 years ago, I started out doing reservoir operations modeling, and then I moved into reservoir operations. Probably the coolest job I will ever have is when I operated Glen Canyon Dam for several years. It's become even more challenging for those operating the facilities. Now, I worked in the Glen Canyon Dam Adaptive Management Program. I worked in dam safety, security, as well as then more recently, I've moved over as the Deputy Regional Director and really have been involved in all the Colorado River issues. And so it's truly a pleasure to be back here, to see so many friendly and familiar faces, and thanks for the privilege to be here and speak about our operations and our infrastructure. So I love reclamation. I know I say that, and I love working for Bureau of Reclamation. I think most people know who we are, but for the two people in here who maybe don't know, we are a federal agency that manages water and power in the arid Western United States, and that's the division line there on the graphic here. And it's primarily through the construction and operation of dams, reservoirs, and hydroelectric facilities. And we obviously play a central role in water delivery, hydropower generation, and importantly, drought response across the region. I like citing what the mission of Bureau of Reclamation is because I love it. It is to manage, develop, and protect water and its related resources in an environmentally and economically sound manner in the interest of the American public. It's public service that we do here. It's truly what the American public, what you all are saying needs to happen. That is what we go forth and do. So it truly, our job, though people say, well, just do it. Yes, we will do that, but it truly is this collaboration, and what makes the most sense for the American public is how we manage our facilities. So great mission. I love working for Reclamation, and this is also where I make the pitch. Anyone from the outside who is looking for a career, or young students, look up Reclamation. It's a great place to work. Specifically for Colorado River Basin, our multi-purpose projects supply water and hydropower to millions of people, 40 million people, as well as it supports agriculture, fish and wildlife habitats, and recreation. And I apologize, I'm using my talking points because I sometimes go off script and I will not get through my talk if I can talk long about each of these topics. So in terms of hydrology and historic water scarcity, we just heard Brad. Thank you, Brad, for all the important, really important information. I know people kind of tease him, but it's really important to have, for us to see not only what we're seeing right now, put it in the context of what we've seen in the past, and truly what we need to be looking ahead towards and to be prepared for. So thank you, Brad, for that very important information. And highlighting it doesn't look good. Operating the Colorado River during this historic water scarcity is intensifying both the challenges we face and the urgency with which we have to address them. With respect to sustained aridification, the basin's shift towards a drier, long-term climate is reducing natural runoff, as we've seen, and shrinking, for us at Reclamation, shrinking our operational buffer that we've historically relied on to meet water delivery, hydropower, and compact obligations. It's reduced our operational flexibility. So these critically low reservoir elevations at our key reservoirs, the large ones on the Colorado River, are constraining our ability to optimize and really optimize the releases for a wide range of resources, because we truly are multi-purpose and really need to look at all of the resources when we're managing our reservoirs. It's made it more challenging to protect infrastructure and maintain dependable hydropower generation. So we've had a growing complexity in balancing all of the various missions. We need to navigate tighter trade-offs among hydropower, environmental compliance, our tribal trust responsibilities, recreation, and our interstate commitments. And it's with less water. Not only is there less water, there's also greater uncertainty looking ahead. And then on top of all that, there's the heightened stakeholder expectations. So states, tribes, power customers, basin communities are increasingly looking to Reclamation for leadership, transparency, and stability as the hydrologic conditions deteriorate. We're seeing an increased frequency of crisis-driven operations, drought response actions that were once rare, that's emergency releases or basin-wide coordination and requiring rapid operational adjustments. Those are becoming routine, and it's requiring sustained leadership engagement, really, truly all the way up to the Secretary of the Interior, as well as significant staff time and expertise. We need a long-term adaptation. I know, I guess I'm repeating back what I'm hearing. Just to state, Reclamation knows this. I think everyone in the room knows this, but it goes without saying it, that the scale and persistence of drought require forward-looking planning, modernized modeling tools, as well as collaborative frameworks. As Brad said, we all can't be done by one entity in the basin, can't be done by half of the entities in the basin. It's going to take all of us working together in order to move forward. So as we all know, the Colorado River is managed in accordance with the law of the river, and that's the compacts, treaties, statutes, contracts, and agreements that legally govern how we operate. The foundation is the 1922 Compact, which divided up the river. And I'm not going to discuss the law of the river. There are plenty people way more qualified to discuss that. But what I wanted to highlight on this is that the next couple slides, I just want to show there are a lot of major components listed here of the law of the river. And that highlights that the rules governing the operations are long and complex, and furthermore, not everyone agrees on the interpretation of these laws. So that makes our jobs, all of our jobs, more complicated and more challenging. So in the first 50-ish years of the law of the river, the primary focus was on the development and the divvying up of the water. And in more recent years, beginning in the early 2000s, following the declining hydrology and storage, the additions to the law of the river were much more focused on responding to drought as was necessary. Over the past couple decades, Reclamation has worked with our partners to build the tools needed to manage through the worsening drought. I think we have more work. We obviously have more work to manage into the future. So the 2019 drought contingency plans added new conservation commitments and drought response authorities. And then the 2024 supplemental actions adjusted near-term operations and expanded system conservation. And so that brings us to this year. Thanks to Brad for giving us a highlight of what this year has looked like so far, and it's really challenging. There's not much water. We've had to move from a focus on really creating these tools as the just in case, and we need something in case the hydrology decreases, to actually putting them to use, and putting them to use in a rapid way. this year was one for the record books, but we truly need to be prepared for that to happen again next year. So specifically in 2026, this year, in response to the poor hydrology and low reservoir conditions, Reclamation announced in April that we're taking additional coordinated actions in 2026 to prevent Lake Powell from declining below critical elevations. Two primary tools are being used: the Upper Basin Drought Response Operating Agreement, DROA, which is the tool developed in the 2019 DCPs, and a reduced annual release from Lake Powell, which was a tool that was developed in the 2024 supplemental EIS. So let me go into a little bit more detail about how we're doing that and what that means. The DROA operations will move approximately 660 up to 1 million acre feet of additional water from our upstream reservoirs this year, Flaming Gorge, from April 26 through April 27. So it's spread out over the season for the year for Flaming Gorge, and that's to help keep Powell above elevation 3,500. Section 6E under Section 6E, we'll be reducing the annual release from Glen Canyon Dam from what was originally scheduled to be 7.48 million acre feet down to 6.0 million acre feet, so a reduction of about 1.5 million acre feet. So combined, these two activities are projected to bring Powell up by about 54 feet, and that will hopefully keep Powell above 3,500. And we're very aware that if it continues to decline, additional actions may be necessary. We're looking out to next March, and we'll just have to continue to see how this year plays out, and importantly, what next year is shaping up to look like. So why 3,500? Let's take a look at a schematic of Glen Canyon Dam infrastructure. I hasten to note when people were looking at my slides, they're like, Katrina, this is so not to scale. Like, it makes it look like there's all this water down below. And so we're gonna fix it, it's not to scale. Just say that much. So Glen Canyon Dam represents a culmination of decades of Bureau of Reclamation engineering expertise. It was built for durability and undergoes a rigorous maintenance and inspection program to ensure the dam's continued reliability. These inspections are paired with scheduled operating tests and long-term maintenance cycles to ensure every component performs as intended. When Lake Powell, so let's look at this. Now, obviously, our priority is safe and reliable operations. What this graphic is showing is the current elevation at the top there, and then elevation 3490 and elevation 3370, and I'll describe both of those. So when Lake Powell's water elevation is above elevation 3490, also known as minimum power pool, releases can be made through the dam's 8 penstocks and power plant and through the 4 river outlet works. Below that elevation, releases can be made only through the 4 river outlet works, which are located about 100 feet down below in the reservoir. The river outlet works, also known as bypass tubes, so we kind of use those terms interchangeably, are 4 large steel pipes that move the reservoir water directly downstream, bypassing the power plant, and generating units. I'll note that there's only 3.4 million acre feet of water below elevation 3490. So the river outlet works are an important operational tool, but they are not the preferred sole release pathway. They provide an indispensable backup. I've liked to use a spare tire analogy. So they're a backup release capability for when the power plant trips offline or for when we can't use the power plant. But relying on them as the only means of releasing water below elevation 3490 significantly limits our operational flexibility. Instead of having 8 plus 4 tubes, we've got 4, and I'm gonna talk a little bit more about those 4 tubes in a minute here. So it's our obligation and duty to operate our facilities safely and reliably to ensure that they continue to meet their congressionally authorized purposes year after year for many, many years into the future. We've invested a whole bunch of money. I'm going off the talking points here. Invested a whole bunch in this infrastructure, and it's important that we protect that protect that infrastructure and those investments that America has made. So because of our obligation, and given the ongoing drought conditions and the increased likelihood of needing to operate below 3490, maybe 5 years ago, Reclamation began conducting enhanced inspections of the of all of our facilities, and specifically the river outlet works, as well as analyses of what the sustained use of operating below 3490 could look like during low reservoir operations. And based on this analysis, we are confident that the river outlet works can be safely utilized below elevation 3490. However, some operational concerns have been raised, and namely, those are the increased potential for cavitation and sediment scouring. So I'm glad some people are out there nodding. What is cavitation? It is when there's a low pressure, there's less pressure, so there's a more chance for air bubbles to degas. When the reservoir elevation is low, if there's a bend in the pipe, you can get this gas bubbles that explode, which then kind of can pit at the steel pipes. Sediment scour is when you're releasing through the penstocks, and then we also have our river outlet works coming out the side. What happens is if you're not right when they're both being used, they kind of balance each other out, the flows. But if you're using just the river outlet works, that sediment, it stirs the sediment, and we say sediment, but like rocks and cobble, and brings it up around in front of the draft tubes where the penstocks would be releasing water, and it piles up, and it can cause this, all of this sediment piles up in front of the draft tubes, which we wanted to make sure, what does that mean? What does that mean for, is it causing scour? Is it going to inhibit our releases? What about bringing the power plant back online? So those are the studies and investigations that we've been conducting. Stick to the talking points, Katrina. You're going to spend too long talking about these details. Okay. So in March, based on these analyses and our initial results from here, in March 2024, Reclamation, we established interim operating guidance at Glen Canyon Dam, and this was after we identified cavitation damage in the river outlet works, pipe coating, not the actual tubes, but the coating of the river outlet works. It was observed following the operation of the river outlet works during April 2023, which was when we were at about elevation 3525. And so below elevation 3550, we are reducing cavitation as formed based on the speed and the flow, and if you slow it down, then you're less likely to cause cavitation. So we've reduced the maximum amount of water, or the maximum release, and that means that it's much less likely to cause cavitation. So the fix is slow down the release. Like yeah, I'm gonna stop there. It's going really fast, 50 miles an hour through the river outlet works. We're saying slow it down a little bit, just like it wouldn't go super fast on a spare tire. Slow it down a little bit. So these limitations reduce the maximum flow that can be released from the dam when the reservoir is below 3550. Since we've issued this guidance, there have been a number of inaccurate claims about Glen Canyon Dam, specifically inaccurate claims about the dam's integrity and its ability to make releases to Lake Mead and to the lower basin. I just want to say, in case you haven't heard me say it already, these release limitations on the river outlet works are not expected to significantly impact Reclamation's ability to provide water to the lower basin. And Glen Canyon Dam can be safely operated within these limitations. So, additionally, Reclamation is pursuing further studies of cavitation, tailrace sedimentation, and minimum power pool operations to identify and develop potential mitigation measures to see what else we can do to better optimize the system. What I'm showing in this graphic, this slide here is the tailrace sedimentation model. We also built a physical hydraulic model to study cavitation in the river outlet works. That was completed last April 2025, and the study concluded that the protruding weld joints and the abrupt changes in the slope within the mitered elbows control the development of cavitation. And so due to the uncertainty in applying The physical model results, the interim operating guidance were recommended to stay in place, slow the release down by about up to 17%. It depends on the elevation. The study also recommends, okay, we've got a physical model, but really it's going to make more sense to actually go out into the field. So do some field testing. We've installed pressure measurements on the river outlet works, the tubes, and when you measure the pressure locally there, and we'll understand what that looks like at various release rates. Studies of the tail race sedimentation and minimum power pool operations are ongoing, and they're expected to be completed later this year, but preliminary results also support maintaining this interim operating guidance when you're try not to go below 3490 if you don't have to. If you do, use this reduced release amount. So these completed, in addition, we've completed and have ongoing maintenance at the river outlet works, and those are allowing our continued functionality and reliability, and that includes recoating the river outlet works, piping, and the rehabilitation of the holojet valves. So those are the valves that control how much water actually, kind of at the end of the river outlet works there, how much water actually comes out of the tubes. The recoating work was completed last June 2025. What it did is it replaced the original 1960s coal tar coating with a new fancy solvent-borne epoxy and polysiloxane top coat. I just wanted to say that because I practiced saying it multiple times. Thanks for your indulgence. So that the recoating of the river outlet works is completed. We are still working on rehabilitating the original holojet valves. I should note, this isn't because of any damage. This is just like getting a new timing belt for your car. It's been 60 years. It's time to look at, as our facilities age, this is planned maintenance. So it's something that we were already planning to do, and we still continue to plan to rehabilitate the holojet valves. So both projects will maintain and preserve the river outlet works' ability to operate within their design parameters and the current operating guidance, including this most recent operating guidance. If our studies give us more information and say, hey, you can operate a little bit more, or hey, you got to dial it back a little bit, we'll implement that. It's not going to be well, I'm not going to project on what it's, we're going to continue to implement the interim operating guidance. I don't foresee significantly different, I don't foresee dramatic changes to that guidance. They may be dialed up or down a little bit based on the initial results that we're seeing. Should be noted that there's no engineering fix or repair to the existing river outlet works that will eliminate the risk of cavitation. Cavitation is physics. There's not an engineering fix to that. That happens when the reservoir elevation is low. I think we can all deduce what a fix to a low reservoir elevation is. So, use of the river outlet works. We've used them a lot, actually, in recent years. We've been relying on the river outlet works more frequently than in recent history due to coal mix flows operations at Glen Canyon Dam, for those of you who are more in the weeds on the GCD AMP activities, as well as high flow events. And those are requiring coordinated releases through both the power plant and the river outlet works. And while the river outlet works remain fully functional and reliable, their increased use underscores the importance of maintaining Lake Powell above the elevations that preserve power plant releases, as well as our operational flexibility, releasing through 12 tubes instead of just 4. So the river outlet works remain reliable, but they do require continued safeguarding. And what I mean by that is recent inspections, studies, operational experience, they confirm that they're performing as designed, but we're going to continue to protect this infrastructure to maintain the reliability in case they're needed more in the future. They're a critical tool, not the preferred sole release pathway. They provide this indispensable backup release capability, but relying on them as the only means of releasing water below 3490 would significantly limit our operational flexibility, the ability to release a wide range of releases. And maintaining that elevation above 3,500 remains essential to ensure dependable water delivery, hydropower generation, and long-term infrastructure integrity. I'm getting close to the end here. I actually didn't start my timer. So low reservoir operations. I'm here to assure you Glen Canyon Dam is in sound condition and fully capable of delivering the water the system relies on if the water is there. Reclamation's recent and ongoing inspections, maintenance, and technical studies have improved our understanding of the potential risks of operating at low elevations and provided recommendations on how reclamation could utilize the river outlet works if needed. In addition to the reduced maximum release, so this slow down the speed on the spare tire, if they're used continuously, what we'll need to do per the original design operating criteria is inspect them more frequently. And what that means is you've got 4, so after 6 months, every 6 months, what you'll need to do is take one of those offline, dewater it, go in, inspect, make sure it's looking okay. If there's any repairs that need to be done, do those spot repairs, water it back up. So at any given time, we'll have 3, maybe 4 online. It takes several weeks to a month, depending on how long it takes to get all of the in there, dewater, do the repairs. So at any given time, we'll have about 3 to 4, 3.5 river outlet works could be used on a continual basis. So we do have the ability to release below those elevation, release below 3490, but it's a little bit, we need to take them off regularly, inspect them, and make sure everything's okay. So the 3.5, it could happen on a 24/7 basis. Okay, we've heard questions about whether the reduced release for our interim guidance and required inspections will limit the total annual release from Glen Canyon Dam. I'll say that even with these limitations, an analysis of the original design criteria versus this interim reduced release rate of up to 17%, it shows that the hydrology, shocker, rather than the limitations on the river outlet works, is a primary driver of the releases through the river outlet works. And what that means is that even though we've got this reduced release, the maximum flow through the river outlet works, the main restriction is the amount of water. We can release the water if it's there. With only 3.7 million acre feet of water below 3490, that's the amount that can be released. It really depends on how much more comes into the reservoir, depends on inflow. So put another way, if you think of Lake Powell's storage below elevation 3490, like a bank account with a small remaining balance, if your withdrawal is higher than the balance of your account, then the withdrawal is the issue. You simply don't have the funds. In that same vein, using the water below elevation 3490 feet isn't a practical solution for regular operations. The balance is so small that drawing it down wouldn't provide a significant benefit in the short term, and concerningly, would leave us with even fewer options for when conditions may be worse. And as we heard from Brad, it is likely to look worse. Okay, so looking ahead, this is my last slide. These limitations make one thing clear: we must plan to move forward with less, and we must do so with intention. Reclamation will continue to inspect, investigate, evaluate solutions, but without improved hydrology, no dam modification can make up water that simply isn't there. That's why preparation and partnership matter more now than ever. A major part of that preparation is already underway. The development of the post-26 operating guidelines, which I'm not speaking about, but Acting Commissioner Cameron is also on the agenda later today, so he may go into some more details on that. It's one of the most significant planning efforts in the basin's history. We expect to complete that work this summer, establishing a clear framework and operations for the next years. But planning can't stop there. We also need strategies that look further ahead. These planning efforts will guide the basin through the next generation of challenges and opportunities. So we remain committed to protecting and managing the Colorado River systems so that all of the water users, the ecosystems, and the communities that rely on a stable and resilient river will have that. The long-term strength, collaboration is the path to long-term stability. We've heard that there are disagreements on how it's the interpretation of the law of the river. We know that we're going to need to use less, and it's going to take all of us, and it's going to take all of us working together. And then I will end with that. And a thank you. It is truly a privilege to be able to speak with you, and thanks for the invitation.
Thank you. Thanks, both of you. Those were excellent. My gosh, we're not anywhere near on schedule. Apparently, someone with the best intentions allocated more time to speakers and questions and break than actually exists. I'd like to think that's Mother Nature's fault for not giving us more time, but we're going to do the responsible thing and make some cuts. So we'll do Q&A, but we'll shorten it up a bit, and then we'll have a break, but we'll shorten it up some to try to get us back on schedule. So, Jason, do we have questions that have come in?
We sure do.
Do we have a microphone? Is there a handheld microphone down there? Oh, you have it. Okay. All right, sorry. Why don't you go ahead and ask the question then?
Will do. So yeah, I'm Jason Robinson. I'm a law prof up at University of Wyoming. Thanks to everyone who contributed questions to the queue. The other thing I would add is, if you like a question that's been contributed, please vote it up, because my colleague Celine and I will really pay attention to that democratically, as it were, in choosing which questions get posed. So it matters. And in that spirit, there's a question that's a state of Colorado specific question that clearly there's a ton of interest in, and it's addressed to Brad. So I'll just read it. Colorado has declared free river conditions, I guess under state law, which apparently allow users to divert without limit, despite the fact that we're in drought. Can you provide your perspective on this declaration of free river conditions in the state of Colorado?
Wow. You know, frankly, this is an area I don't much work in, right? And most of the time, but not always, I try and keep myself in the science, right? But not always. And I'm quite unusual, right? I mean, most scientists don't go wade off in the policy thicket. I have this very unusual background that I don't think anybody could ever reproduce if they tried. And I feel sort of inadequate to answer that question, actually. It doesn't seem that great a place to be this year, though. I mean, if you really want a personal feeling about that. Wow, in a year like this, maybe it makes sense, though. And that's partly why I'm hesitant to answer this. I'm sure there are probably better people in the room who could provide some insights on this.
All good. Like I said, I'm watching the queue. That got 15 votes, so that's why I wanted to throw it out there.
I'm sorry to disappoint you with such a lame answer.
The other topic, predictable one, that got a lot of attention was Glen Canyon Dam. There are probably 5 questions in the queue about Glen Canyon Dam. So I'll come back to both of you for this one. I think the first part of it might be best suited to you, Brad, and the latter to you, Katrina. Could you talk a little bit more about the relationship between Bureau of Reclamation operation efforts to protect critical elevations and compact deliveries, the compact tripwire? The way that the question is posed is, what will Bureau of Reclamation operations to protect critical elevations look like for compact deliveries, given that it looks like we're going to hit 3510 at Lake Powell in September? That's the first part of the question for Brad. And then, Katrina, the piece for you would be, is there any more beyond what you shared in your presentation regarding operational changes or infrastructural modifications that you think might be relevant in that space?
All right, so here I will wade into policy. And So I'm sure everybody in the room, I hope everybody in the room is familiar with Compact Article 3D, the non-depletion obligation. And for years in the 20th century, scholars like David Getches and Charles Wilkinson and Charlie Myers said that this was in fact not a non-depletion obligation, but it was a delivery obligation. And that's not what it is, right? But in a world without climate change, you could actually make that leap to get there. But in a world where flows at Lee Ferry can fall below 75 million acre feet, not because of upper basin depletions, but because of Mother Nature, then you have a whole nother cause out there. And I don't think anybody in this room knows what that cause means in an era of climate change. I mean, we can't know. And, you know, on the two boundaries, to me, I mean, clearly the upper basin will not have caused this. On the other hand, the upper basin has some kind of delivery obligation in the lower basin. I don't know what that number is, but it's there somewhere. And therein, in fact, lies, I think, you know, one of the fundamental disagreements that we're facing right now. What does that Article 3D mean? And I don't have any particular advice for decision makers on what that means. I mean, clearly within the compact negotiations was this idea that we were going to share between the upper basin and lower basin equally. I mean, that comes out so clear in the compact itself and in the negotiation minutes. You can read it in Norris Hundley's book. But where do we go with that? I don't know. And I don't know that I completely answered the question as posed, but those are my thoughts.
Thank you so much. The reference to conservation provides a good springboard for a final question, but only if I've got Doug's approval. We're good? Okay, one final question. And this one's directed towards Brad, though I'm sure that the person who posed the question would welcome any of Katrina's thoughts. Brad, you mentioned buying out demand, and it brings to mind, among other things, maybe Murray-Darling Basin, perhaps other basins across the world. The question is how to achieve this on the federal, state, and local levels. In particular, what role should the federal government play in buying out demand? The way that the question posed it, can the feds control alfalfa growing and exports?
Wow. So I've written a lot about alfalfa, and I'm really sensitive to Family Farm Alliance's term of crop shaming here. I wish it weren't grown, but I think we don't serve purposes by telling farmers what and what not to grow. It's a really great crop for farmers. Should we be growing at Colorado River Basin the quantities we do and other forages at like 50% of water, of the ag water? Probably not. But if we're going to cut back farmers, they should decide what they want to grow, not us, I would argue. My point to get into cutbacks is, I mean, it's the obvious solution here, and who should pay? The federal government, man. And maybe the states to some degree, but the feds. And the feds, John Ensminger often makes the point that, you know, the feds often dump tens of billions of dollars post some kind of hurricane mess in Florida. I mean, this is not dissimilar from that. It evolves very differently, but it's not dissimilar in terms of people impacted and seriousness and need. You know, would that money be hard to pry out of the government? Absolutely. But that's where I think it comes from. The prioritization of it's going to be really challenging. And if you think about it, it would be it would be somewhat easier to do in the lower basin that you got reservoir releases, right? I mean, you kind of know where this water's going. And maybe the states keep their allocations, but in fact, there's some side agreement where they actually have to use less. The upper basin is a completely different challenge, and that gets kind of to the point of upper basin contributions to solving this, in that if diverters stop diverting, do you have any guarantee that that water actually makes it somewhere and isn't diverted by somebody else? That's a difficult challenge. And the Murray-Darling, they've used, you know, what economists love, reverse auctions, right, to try and get the best price. But there are all these other values that would have to go into that kind of procedure where you'd want to look at, total water use in an area and cultural values and economic values and be really sensitive to the communities that are going to be impacted by this so you don't overtly impact one particular community. And we've learned that lesson the hard way, right, from LA's water grabs in the Owens Valley and here in Colorado in Crowley County, which is a story that's not much told, but very similar, harsh, ugly impacts. So, I just don't see a solution other than it's the one thing we control, demand. And to the extent we continue to have all these straws in every year, somebody's going to be disappointed. We're going to waste money buying out people on some kind of temporary basis. And I'll make kind of a little bit of an outrageous claim, but I think, the money that was spent out of the Inflation Reduction Act and the other bill to buy out, that was not well spent money. That money should have been spent on permanent buy downs. And we shouldn't make that mistake again.
I hate to do this. I hate to do this, but we got to get back on schedule, I think. So I think I'm going to stop the questions there. I will encourage you to, I always want to say corner, and it sounds so hostile. I want you to cozy up to Brad and Katrina when you get a chance and maybe ask them your questions one-on-one. I think that would be, that would work. Are you sticking around for the whole thing?
I'm around for the conference, yes.
Okay, good. So that's what I will recommend. We're going to take a break. It's going to be a short break. Sorry, we're going to try to come back on schedule, which means at 10:15, which means 11 minutes from now. I know. But we're going to try. Thank you.
Thank you.